Hi everyone. So this video is going to be about the method of substitution for solving simultaneous equations. So in the previous video, we looked at solving simultaneous equations by equating values of y. So that worked really well when you had two equations that were both written as y equals something. Great. If we look at the two equations that we're asked to solve in this particular example, we only have one of those equations that's written as y equals, the other one is not. So that solution method of solving by equating values of y, that's not going to work. That is just not going to work because you don't have both equations written as y equals. So instead, we need a different method. So that method is known as substitution. So to substitute something, you replace one thing with another. So what we're going to do in this particular type of question is we're going to take what y is equal to in the equation that's written as y equals, and we're going to substitute it where we see y in the other equation, which is kind of like what we were doing anyway. In the previous example, if you had y equals 2x plus 3 and y equals x minus 4, you took what one of the y's equaled and you replaced it where the other y was, so you ended up equating your values of y. But it's the same idea, so that's why I kind of refer to these two methods as two sides of the same coin. Okay, so let's dive a little bit deeper into this example. So what we're going to do is we're going to take the equation that is not written as y equals, and when we get to the y, we're going to replace that with what y equals in the other equation. So this is where the y existed in the previous equation, so instead we replace that with what y was equal to in the first equation, which was 2x plus 3. Now, we just go ahead and solve this using our linear equation solving rules. So we're going to start by expanding brackets. So in this one, we need to pay a little bit of close attention here because what's multiplying into this set of brackets is in fact a negative 4. So our next line will read 3x minus 8x minus 12 equals 8. Then we're going to combine our like terms, which in this case is 3x minus 8x. So that gives us negative 5x minus 12 equals 8. Now we need to get everything away from x. We already have it consolidated on one side, so we don't need to worry about that particular step. So our next step here is going to be to add 12 to both sides. So that results in negative 5x equals 20. And then our final step here will be to divide both sides by negative 5, giving us an answer of x equals negative 4. All right, so we're halfway there. We have figured out what x is equal to. Now our last step is to figure out what y is equal to. When we were equating values of y, it didn't really matter so much which equation we chose to do the last part, because both of the equations in the previous section were both written as y equals. They were both already set up to easily solve for y. While you can still use both equations here, and they will still, done correctly, result in the same answer, there is a definite one that makes more sense to use. It makes more sense to use the equation that is already set up to solve for y. So that's the one that I'm going to pick, and that's the one that I would also suggest that you pick. So we've got y equals 2x plus 3. So we're going to take what we solved x to be and replace it where we see x, so substitute in that x value, and then we're going to solve. So that gives us negative 8 plus 3, so y equals negative 5. So we have a final answer of x is negative 3, y is negative 5. And that's how the method of substitution works.